Welcome to your pre-lab for the Newton's second law lab. Okay, let's start with what we know so far about forces. So we know that one option for our forces is that they're balanced. This is a force diagram where we have balanced forces. We know that the F net is 0. What do balanced forces mean for the motion of the object? Well, it means that our object's motion does not change. Either it's staying stationary or it's moving at a constant velocity. In other words, our acceleration is 0. So we see a connection here. F net equals 0, acceleration equals 0. But what if our forces are imbalanced? What happens if we have unbalanced forces? That's to say, all the forces do not cancel out here. This would be an example of unbalanced forces. We know that F net is not going to be equal to 0. It's going to be something greater than that in some direction. We know that the object's motion is also going to change. It could be speeding up. It could be slowing down. We don't really know what it is, but it is going to be changing in some way. So our acceleration is not going to be 0 anymore. So when F net is not 0, acceleration is also not going to be 0. We're going to have some form of acceleration. The purpose of the Newton's second law lab is to quantify the relationship between F net on the object's mass, and the object's acceleration. AKA, we're going to come up with a mathematical model that relates mass, F net, and acceleration.
All right, here is a picture of the setup for our lab. Again, we're looking at F net, mass, and acceleration. So we're talking about the acceleration. We're talking about the acceleration of the cart. For its acceleration, we're going to be able to measure that by using the start mark, the end mark, which can help us find displacement. You also have your stopwatches available if you need to collect any time data. But between this displacement data, the time data, and a few other things that you'll be able to assume about the cart's motion, you should be able to solve for its acceleration from here to here during its motion. Now, how are we accelerating the cart? You can see from the setup here we have a string that's attached to a hanging mass. And this hanging mass is going to supply our F net that's being applied to the cart. Change the hanging mass, you change the F net being applied to the cart. And then finally, the mass of the system. Now, the system that we're looking at is not only the cart itself, it's also the mass that's here. So when we keep mass constant, we don't just want to keep the mass of the cart the same, we want to keep the mass of the overall system the same. Okay, so these two masses together would need to remain the same whenever we keep mass constant. Okay, so I kind of forgot to record this part during class, so I had to record it during another class. So I'm just voicing over it because I couldn't talk. Whoops. All right, so here's the setup. We have the cart over here. Here's the start line. Here's the end line for the motion where you're timing the cart. We have the string and the weight that is going to pull on the cart. And when I let go, move the book out of the way, and let go of the cart, we see it accelerates, and we can measure that acceleration. One last note on the setup. So to measure the net force that's being applied to the cart, we need to know how hard this weight is pulling on the string, because then the string is pulling on the cart. In order to measure that force, we can take the weight, hang it on one of our force sensors, and our force sensor gives us the value of the force in newtons. So that would be applying a force of 0.5 newtons to the string, which is applying a force on the cart. Then I can hang the mass back on the string.
We're going to break up this investigation into two parts. In part one, you're looking at just the relationship between F net and acceleration. You want to determine what that relationship is. So you'll be changing F net to see the effect it has on the acceleration of the cart. Mass will remain constant, the mass of the entire system, and we'll talk a little bit more about what that is when we get into the actual lab itself. So changing F net, seeing the effect it has on acceleration is part one. Part two, we're going to look at the other side of it. So we're going to keep F net constant, so we're not going to change the force that's acting on the cart. We're going to change the cart's mass. So you're looking at the relationship between mass and acceleration, so you'll be changing the mass of the cart to see the effect it has on the acceleration of the cart. So to summarize, as part of the lab, you're going to be, part one, you're looking at the relationship between F net and acceleration. Second part, you're looking at mass and acceleration, the relationship between those two. And in all, you'll be able to come up with an equation that relates F net, mass, and acceleration. that's our goal for the Newton's second law lab. Thanks for watching, everybody. More details will come in class.